Hello students, now come to the next topic of the chapter number 4, some basic concept of chemistry of class 11, empirical formula we will discuss in this lecture. So what is empirical formula? An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas molecular formula shows the exact number of different types of atoms present in a molecule of compound. Means, for example, if I say that CH2Cl, that is the simplest formula, and if I say C2H4Cl, that is the molecular formula. Carbon has two atoms, hydrogen has four, chlorine has one, chlorine has two. So in this way we can name it. And CH2Cl means it has the simplest one. So this is the key difference. Empirical is the simplest, molecular formula has exact number of atoms. So now come to the numerical based on it. It has very important topic, especially for the numerical point of view. Question is that on your screen is a compound contains 4.05% hydrogen and 24.27% carbon and 71.65% chlorine. So its molecular mass is this, then what are its empirical and molecular formula? So whatever the data is given, first we make a table. In first section we will write elements of atoms, and relative number means number of moles, and the simplest number, or we can say smallest number. Hydrogen, carbon and chlorine, these atoms is written on here, and in front of hydrogen we will write it 4.07 upon 1.008. exact mass we are taking, but you can take it only one on here. On calculating it we will get 4.04, and the percentage abundance next. In this way we will take 24.27. 4.07 is the percent abundance of hydrogen. Here we have taken. Now we'll take 24.27% abundance of carbon divided by 12. 0.01 is the exact mass of atom, but you can use 12. So after solving it you will get 2.021 something answer. Chlorine, for chlorine atom percentage abundance is given 71.65, and on divided by 35.453 not taken. If you will not take it 453, then take simply 35.5, because on rounding of these number into one decimal place, so we will get it 35.5. So we'll by calculating it we will get 2.021. Now we will see that which is the smallest number by the calculation of these hydrogen and carbon and chlorine number of atom. That is, these two number are smallest and exactly same. So on dividing from one of these number into these all numbers, 4.04 upon 2.021, we will get near about, we will get 2. 2.021 upon 2.021, in its own self it is divided, so we'll get 1, and in this way we'll get 1. So number of simplest number we will get, C has 1, hydrogen has 2, and chlorine has 1. So in this way we will get CH2Cl. So and we'll calculate molecular formula is just like CH2Cl whole twice. And how the 2 will get? We will get 2 by this formula. N is an integer. While calculating the integer, the formula is molecular mass upon empirical formula mass. So molecular mass is given 98.96, and so on calculating it we will get N is equal to 2 number of moles. So molecular formula, while calculating CH2Cl, we will multiply its all integers value of each element, so we will get C2H4Cl2 by 2, because N is 2. So in this way we can calculate easily the empirical formula and molecular formula. On repeating, first take the percentage abundance divided by the atomic mass. On solving for each element, then divide by the smallest number, the calculation, and divided by the smallest number with each and every number of this calculation. So we'll get simplest ratio, and in terms of simplest ratio we'll multiply By these ratio on each element we will get the empirical formula, and for calculation of molecular formula we will first find a number of integers, and while getting and after getting this value of n we'll put into the molecular formula in each element, so we'll get the exact number of atoms of each element, so we get molecular formula in this way. Now the second question is just like this. In a similar way, determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen by mass. Here it is one point to be remembered, that if any compound is ionic form, means here is iron and oxygen, both are in ionic form. So we, in this way, the empirical and molecular formula are same, and if the compound is non-polar, like just like a CH2Cl or any organic compound, and it can be have two values, as empirical formula and molecular formula. Here empirical formula and molecular formula is same. So now on calculating it, elements relative number, same concept on here. Here are two elements given, iron and oxygen. Percentage abundance divided by atomic mass. Percentage abundance 30.1 divided by atomic mass 16. Same procedure, 1.25, 1.88. On dividing, smallest number is 1.25 we will get while dividing it, and this number. So 1.25 is divided by 1.25 we will get 1. 1.88 divided by 1.25 we will get 1.5. And on multiply by 2 to get whole number. So 15 to the 30 and 1 into 2 is 2. So we will get exact value 2 and 3 for Fe2 and O3. The empirical formula we will get on here. So n is equal to molar mass upon formal mass. Both are same, so it is equal to 1, and molecular formula is also Fe2O3. So in this way, I hope you will understand how to calculate the molecular formula in the numericals, or empirical formula in the numericals. Now come to the next point, significant figures. What are the significant figures? Significant figures are the meaningful digits which are known with certainty. It means it has some certain value. For the rules for writing the significant figures, this significant figures is used in finding the values and errors, while sometimes has happened in the instrumental things while calculating the reading. So this significant figure is used on here for the precision or minimize the error and getting the precise value of any quantity. So rule number first, all non-zero digits are significant. For example, 285 has three significant figure. It means in this number there is no zero digit, so we can calculate three value 1 2 3. And for example, all non-zero for example non-zero digit, if the number is written in decimal form just like 0.25, so it has two significant figures. Zero is not considered on here. Rule number 2, zero preceding to first non-zero digits are not significant. It means if the zero is written after decimal is just 0.03, it has not considered. If there will be some value, then it can be considered. So it has one significant figure. If in the next example 0.0052, if before decimal has any non-zero value, then it can be considered. But if before decimal there is only zero, so these value will also not be considered. Only these non-zero digits are considered as a significant figure, so it has two significant figures. Rule number 3, zeros between two non-zero digits are significant. For example, 2.005 has four significant figures. 0 at the end or right of a 0 at the end or right of a number are significant provided they are on the right side of the decimal point. For example, 0.200 has three significant figures, and 0 behind the decimal or behind any non-zero number can be considered. So this rule want to say this thing. So it has three significant figures, and 0 placing and next after placing 0 from decimal can have infinite number of significant figure. For example, 2.000 has 1 2 3 4 5 significant figure, and if I write infinitely 0, so it can have infinite number of significant figures. So in this way, I hope you will understand this concept of significant figures and writing the value of any significant number. So I hope you will understand this video. So please comment how you video like it, and subscribe the channel, and can write some suggestion if it is there. So in this way I will bring for you a new content in the series of 11 chemistry or 12 chemistry at my channel. Thank you.